Good morning, Algebra 2 students. Hopefully you can see my screen. You can see here we've got all of our vocabulary, which is awesome. And hopefully you filled in your vertical and horizontal asymptotes. Those are going to be those boundary lines that are going to be so key in section 6.1. So when we look at 6.1, we're seeing that this is called the reciprocal function. And it's called the reciprocal function because we see that it's y equals 1 over x here in this parent function space. And that is just to say that the function is itself a reciprocal. So that just means it's a fraction. We have an HK form where a is the numerator, which is always a is equal to the multiplication factor, the stretch, compress, or also the reflect factor. So remember, if a is larger than 1, it will stretch. If a is smaller than 1, it will compress. And then if it's negative, it will reflect it over the x-axis. And then the HK is going to be a very important ordered pair. And remember, we switch the H to make it positive, and then the K is always as it is. So when we are graphing this reciprocal function, we need to understand the parent first. So to do that, I'm going to create a table, X and Y, and I'm not going to plug in just the standard values because this function is so interesting. I'm going to plug in -10, -2, -1, and then I'm going to plug in -0.5 and -0.1. And then I'm going to do all the positives also. So if I plug in 0, that'll be helpful. Then I'm going to have 0.1, 0.5, 1, 2, and 10. So we've got a lot of these to do. And we're plugging them in as the x value. So it's 1 divided by -10. And so if you don't have a calculator, you definitely want to grab one to fill these in. So 1 divided by -10 is -0.1, according to your calculator. 1 divided by -2 is -0.5. 1 divided by -1 is -1. That one was easy. But then 1 divided by -0.5, that's -2. And then 1 divided by -0.1 is -10. So we're seeing this really interesting idea here. When we have a large number in the denominator, it creates a very small number. But then when we have a very small number like 0.5 or 0.1, it creates a very large number outcome. Very interesting. Try dividing by 0. You'll see that that's no solution. And so this spot here is going to become very important, very crucial. We have no solution here at the origin. That's what's going to generate our vertical asymptote here and a horizontal asymptote here. 0, 0, no x value of 0 and no y value of 0 is permitted on this function. And so this creates the asymptotes. So I want you to draw those vertical dashed and vertical horizontal line through the ordered pair 0, 0. Going forward, the HK is going to be the intersection. Sorry, I said that wrong. Intersection of the asymptotes, which is going to be really cool. And so seeing here that our x and y axis do not have any values touching them, that means that for this parent function, the x-intercept does not exist, nor does the y-intercept. We'll never touch those axes for this parent function. This is very unique. This is very interesting. What does that mean for the domain and range? Well, these are the only excluded values. So the domain is still going to go from -infinity to infinity. And remember, this is the x-axis. So now I'm looking at the domain. So the domain starts at -infinity when we're reading it this direction, left to right. And then it goes until the x value at the origin. What's the x value at the origin? It's 0. But we stop there. And so I'm going to use the close parentheses, which means that not including 0. But then there's another space where the domain exists, which is union from 0 to infinity, which is pretty interesting. Let's graph this function. We can plug in all these other values. We're going to have 10, 2, 1, 0 0.5, and 0 0.1. So we've got a lot of symmetry with these numbers. So I'll start by plotting -10, and I'll put these in just a slightly darker shade. -10 and -0 0.1. So that's going to be about right here. That's my good estimate. Then at -2, I'm at -0.5. That's like right here. At -1, I'm at -1. At -0.5, I'm at -2. And then at -0.10, so very close to the origin, I'm at -10. So we're seeing this lovely, interesting shape. So when I connect it, I know that it would continue getting closer and closer over there. And you see that it's making this shape. Very cool. Then we meet the asymptotes. We can't go past those, and we pick up on the other side here. At 0.1 positive, we're up at +10. Then at 0.5 positive, we're at 2, just like halfway. Then we're at 1, 1. Then we're at 2.5, go up half a unit. And then we're at 10 and 0.1, just right, really close to that. And again, we're having this arc shape, this like bendy shape like this. So without the asymptotes, this is the shape that it makes off to the side here. So we see that the range has the exact same shape as the domain. The range starts at -infinity and goes up. We see the arrow pointing up to +infinity. So just like the domain, the range is -infinity. Then it stops at 0 where there's like a break, and then a new piece starts just above 0 and then goes to +infinity, which is very weird. And so remember, the increasing or decreasing interval is going to be mapped to the domain. So this domain is very weird. And going forward, this is going to be the H, and this is going to be the K. So you just want to write those above. The H value is going to create that vertical asymptote, and the K value is going to create a horizontal asymptote. So if I trace this function, my finger goes down overall. So there's no increasing interval. This is a decreasing interval on the exact domain, which is -infinity until 0. Put the H above it, union 0 to infinity. Is this function 1 to 1? Does it pass the vertical and horizontal line test? And we do see that each ordered pair has its own, is totally unique. And so visually, we might say no, but mathematically, we're going to say yes. And then for the horizontal asymptote, that's going to be x is equal to, and a vertical, nope, horizontal is y is equal to, sorry. Y is equal to, and vertical is x is equal to. So the horizontal looks this way, and that's going to be at 0, but then going forward, it's going to be at y is equal to k. And the x is overlapping 0 again, and that's going to go forward at x is equal to h. And that is easy for me to remember because h is an x value and k is a y value. So just to refresh our transformations, we're going to look at if a is negative, then what do? So this is the a is positive shape. So that's going to flip around. It's going to look like this. And then we're going to say reflect over x axis. That's how we describe it. If a is less than 1, we're going to say compress by a. If a is larger than 1, we're going to say stretch. And you might even want to use the word by a factor of A in both of those cases. H, remember to switch the sign from the equation. And this will be shift left or right H units. And K is the same. And so this one is going to be shift up or down K units. And K is going to, again, it's going to be Y equals K as the horizontal asymptote. And X is equal to H as the vertical asymptote. So identifying H and K is going to be the most important first step. And then every single time we're going to have this weird bendy shape, which is made up of two shapes. And you can see that as we get closer and closer to each infinity, we're seeing that the function overall, let's look at this graph a little bit more. Can I? So we're seeing that the function tends toward the asymptote. It's getting really close here. My graph, I didn't do a great job, but you can see I did a really good job graphing this over here, where it's almost touching the asymptote. And again, over here and down here, I did a good job. It's almost touching it, but it is not ever meeting the asymptote. And this is the right way to draw it. This ordered pair here is going to be 1 for X and then A for Y. This ordered pair over here is going to be -1 for X and then negative A. And so those ordered pairs are going to be really, really, really important. Let's take a look at an example that has some numbers. So we're going to start here. We're going to identify A, H, and K. So lame, A is 1. H is, we switch it, 2. K is 5. And so the first thing we need to do here is identify HK as an ordered pair. That's 2, 5. And now we sketch the asymptotes. Oh, I forgot my E. Here's HK. So I find my 2 for X, 5 for Y. 1, 2, 3, 4, 5. And I sketch a vertical line through here and a horizontal line through here. And now I'm going to go and list my horizontal line, asymptotes. The horizontal line is at 5. Y equals 5. The vertical line is at X is equal to 2. So this function will have an X and Y intercept, whereas the previous one did not. So let's do the domain. So the domain will go from negative infinity until, and then where's the X asymptote? It's at 2. And that's going to be union with 2 to infinity. And we always start with negative infinity. So then doing the range, we'll do the exact same thing, but we'll start with negative infinity, and then we're going to go to the Y value, which is 5. And that will be in union with 5 to positive infinity. We don't know the increasing or decreasing interval, but we do know yes for 1 to 1. So now I'm going to make my table. So since it's just the A value of 1, I'm just going to use the table values from before, and I'm just going to use a few of them. I'm going to use -2, -1, -0.5, and then I'm going to use +0.5, and then +1 and 2 as my X values. And then I'm going to generate my Y values. It's going to be -0.5. It's going to be -1, -2. Sketching to remind myself these are the asymptotes. Then I'm at +2, I'm at +1, and I'm at 0.5. So I'm just dropping out those tens. So I'm going to now pretend that HK is the origin. So if I wanted to, I could now make my transformation table, x plus h and ay plus k. Okay, I can make that table by saying these x values plus 2, and then these y values plus 5, but I find that to be really challenging. So I'm going to pretend that this is the origin. And I'm going to go from here -2 units and then down half a unit. That's -2 and then down half a unit. That doesn't look great. Let's try that again. Okay, good. Let me zoom in here. Then I'm going to go from back to my origin. I'm going to go -1 unit and then down 1 unit. Then I'm going to go from my origin -½ of a unit and then down 2 units. And then I know that I'm going to stretch, and I'm just going to put my arrow right here at the asymptote and connect. Wow, it's harder than I thought it would be. And then over here and connect this way. That looks really beautiful. Okay, on the other side, I'm going to start at 0.5. So that's going to be, I'm going to go half. So I'm starting at my origin. I'm going to go half a unit to the right, and then I'm going to go up 2 units. 1, 2. Then I'm going to go 1 unit to the right and up 1 unit. So finally at a special ordered pair. And then I'm going to go over 2 units and then up half of a unit. And then again, right next to my asymptotes, drawing those arrows to connect. And look at this gorgeous function that I've made. So this is very beautiful. I can see here that this is my y-intercept and here's my x-intercept. So I know that they exist. I know that they're both positive, and I'm going to have to run those calculations through my calculator, which we have done in the past. So let's do those calculations now. For the x-intercept, I'm going to do that work in blue. You may recall that we set y equal to 0, so it's going to be 0 is equal to 1 over, and then let me just refresh my memory with the exact function, x minus 2, and then plus 5. So we want to add, subtract 5. -5 is equal to 1 over x minus 2. Then we're going to do that great switcheroo. Oh my gosh, I'm like almost out of space. We've got x minus 2 is equal to 1 over -5. And then I'm going to add 2. And I'm going to think of this, -1/5 is going to be -0.2 plus 2. So that's going to be positive 1.8. So writing that as an ordered pair, that's 1.8 for x and 0 for y. And confirming this does appear to be at 1.8 for x, pretty similar to that. So then for the y-intercept, I'm going to do that in green. And that's going to say y equals, and in this case, I just replace x with 0. 1 over 0 minus 2 plus 5. So that's going to be -1/2 plus 5. So -0.5 plus 5. That's going to be 4.5 exactly. Yay. So that says 0, 4.5. And now for the increasing and decreasing, I know I'm going to use the domain. I just don't know if it's increasing or decreasing unless I trace it. So when I trace it from left to right, my finger goes down. So that's going to be decreasing. -infinity until 2, union 2 to infinity, meaning there's no increasing interval. Finally, for the transformations. Okay, can I type in here? I'm going to describe A, no change. I'm going to describe H. H was 2, and that was 2 units to the right. So shift right 2 units. I'm going to describe K. K was positive 5, and that's up 5. So shift 5 units. The end. That was great. Do we have a couple more to do? Yes, 1, just one more to do. So this one is great because we finally have an A value that's not just boring old 1. And we're going to get to see how A is used here, which I love. And so overall, we're going to need to make a transformation chart. So identifying A as, what is it? -3. The negative sign belongs to the A. The H is 0. There's nothing down there with X. And the K is -4. So the HK is going to be at 0, -4. So I begin by plotting that. 0 for X, -1, 2, 3, 4 for Y. And I sketch my vertical and horizontal asymptotes. So here's X, here's Y. So the X value is the vertical, that's X is equal to 0. And the Y value is horizontal, that's Y is equal to -4. And is this 1-to-1? Yes. And then I see that there's an asymptote overlapping the y-axis. So that means that the y-intercept does not exist. Okay, so the domain and range, we could do the domain. The domain would start at -infinity. It would stop at the x value of 0, so union 0 to infinity. And then the y values will do very similarly, starting at -infinity, going until the y value of -4, union -4 to infinity. Okay, so now let's make our transformation table. So I'm going to make 3 columns here. I'm going to have X, I'm going to have Y, and then I'm going to have A times Y. So this is going to be -2, -1, -0.5, and then 0.5, 1, and 2. This, I hope, will be enough numbers for me. And then I know this is -0.5, this is -1, this is -2, this is 2, this is 1, and this is 0.5. All right, I'm getting pretty good at this. Now in this really great orange color, I'm going to change this from AY to -3y up above. So I'm going to take my y values and multiply them by -3. So that's -0.5 times -3, which is +1.5. So we see that we switched signs, and that's what creates the reflection. So from -1 times -3, that's going to be +3. -2 times -3, that's going to be +6. 2 times -3, -6. 1 times -3, -3. And then here at -1.5. Right on. So now I'm going to cross this one off. I used it just to generate these. And so then just like before, I'm going to pretend that my ordered pair here is the origin. And I am going to go, in this case, -2 units and then up 1.5 units. So I go -2 units, 1, 2, and then up 1.5. Next, I'm going to go -1 unit for X, and then I'm going to go up 1, 2, 3. Then I'm going to go half a unit for X, and I'm going to go up 6 units. 1, 2, 3, 4, 5, 6. So we're seeing how the stretch, I got these little dots here, need to erase those. I'm right next to the asymptote. I'm right next to the asymptote with my arrows, and I connect. All right, now I'm going to go half a unit positive, which is about here. And I'm going to go down 6 units. 1, 2, 3, 4, 5. Oh, thank God. I just made it in. Then I'm going to go 1 unit to the right, and I'm going to go down 3 units. 1, 2, 3. And then I'm going to go 2 units to the right and down 1.5. And so coming over to my asymptotes to create the arrows at the end. I now connect. And this looks pretty good. So comparatively, we can see that stretch is creating distance inside of here and inside of here. So that's pretty interesting. But I can't just undo that. So now let's find those intercepts that we haven't found yet. Looks like we have to, oh, let's do the increasing and decreasing interval. So now when I trace this left to right, my finger goes up. So this one is increasing. So when we have a negative A, it creates an increasing interval. So this one is going to be negative infinity until 0, union 0 to infinity, and the decreasing interval will not exist. All right, so to find the x-intercept, I'm going to use blue. Oops. And that's going to say x-intercept. Again, we set y equal to 0. We've got negative 3 over x minus 4. And I'm going to solve for x. I'm going to add 4. That's 4 is equal to negative 3 over x. Doing the switcheroo, I've got x is equal to negative 3 over 4, which is negative 0.75. Visually, am I seeing that? Yeah, pretty close, just with even just my graphing. So that's going to be negative 0.75, comma 0 for y. And then now we're going to list the transformations. So the a value, negative 3. So to describe that, I'm going to say reflect over the x axis. That's for the negative part. And stretch by a factor of 3 because it was 3. I'm going to make this wider. Okay. Next, I'm going to describe, cancel, the next value. So we've got, oops, I have a G in there. The H value was 0, so I don't list H, but K is equal to negative 4. So to describe that, I say shift down 4 units. The end. We are now done with our transformations. So this was a lot of fun. So you can see what we're going to be doing differently here is we're going to be creating this transformation table. This is the one that you're going to want to make anytime we have an A value. We have X, Y, and then we just have AY instead of X plus H and AY plus K. Because there are so many decimals in this function, this is going to really help us because adding and subtracting with decimals can be really tricky. So have fun. I can't wait to help you with your homework. Goodbye.